All right, you're welcome back once again. My name is Victor Digomo here, and in continuation of the classes we've been having, we've done some classes in algebraic expressions, and we are delving into quadratic equations. And in quadratic equations, if you check out the previous classes we had, you realize that we've been able to do some activity around the cubic equations. Yes, you've done some activity there. We have been able to see how you can divide a given polynomial function by another polynomial of a lesser degree. So these are the things we've looked at under algebraic expressions already. So it is necessary you take out those classes because it's going to build up in what we will be doing. It is going to help you to understand and follow us in what we are doing already. Okay, now we want to see there's something area I want to look at, that is completing the square method of solving quadratic equation. But in that completing the square method of solving quadratic equation, there's something we are going to come across, and that thing is perfect squares. So I looked at it and I realized that it is necessary I help us to understand perfect squares so that when I will be discussing completing the square method of solving quadratic equation, one can be able to follow when we reach at that spot where we'll be talking about perfect squares. And yeah, one need to understand. So without taking our time, what we are actually going to look at right now is understanding perfect squares. Do we get that? Understanding perfect squares. Now, when we talk about perfect squares, what exactly are we talking about? Perfect squares. What exactly are we talking about? You may have come across it here. When we say perfect squares, something is a perfect square. That is to say that such a thing, such an expression, such a mathematical expression, or such a value can be expressed in two factors that are the same. Yes, take for instance, we have figures like 4, 9, 16, 25. These figures, we they have they have factors. They have factors. If you look at this has two factors, which is 2 and 2. These have two factors, 3 and 3. These have two factors, 4 and 4. These have two factors, 5 and 5. So this you can call this perfect squares. Okay, so we will build from here. If you understand that this is a perfect, we can call this perfect squares. If you understand that, if you embrace that, we can move a little bit further. I hope I'm making sense here. We can build on that and begin to talk about an expression that we can say that this expression is a perfect square. It can be a quadratic equation. Okay, take for instance, if I have something like x squared minus 4x plus 4 equals to 0, you know that this is a quadratic expression. This quadratic equation, it can be expressed in two factors that are the same. Let's look at it. The approach I'm going to take is factorization. Remember I said that where this perfect square, the concept is going to be used is when, because after this class, I will be talking about completing the square method of solving quadratic equation. So when I come across that, I would like you, if you are following me, I would like you to understand what I'll be talking there. You understand? There is an expression. Let me not take our time. If you follow me, you just get everything will be discussing. So I want to factorize this now. It's just like I'm trying to, discuss factorization method of solving quadratic equation. So if this is your first time of, seeing this, there is something I'm going to show you. Factorization method of solving quadratic equation is very simple. So you realize that simply we take a product of this and this, and we will have 4x squared. So we'll now be looking at this expression and check how can we be able to find two factors of this expression, of which when we take a sum of it, it will give us this middle term. Okay. I'll begin to look at it and see if I can be able to do that by try and error. You realize that I can be able to. Let me not take time. I'll just go straight and put up something there. You are going to see with me that is acceptable. If I put up two factors here, let me focus on these two, this four rather, this four, this four. Do you think I can express this four as let me say two here? Let me say two here. Let me say two here. 2 times 2 will give me 4. Huh? And if I attach s here and attach s here, 2x times 2x will give me 4x squared. Whoa. So, another thing, with 2x plus, we are saying sum being this. With this and this, give this. The sum of this. No, it's not going to do that. You realize that the sum of this and this is going to be 4x, and this is minus 4x, and we're looking for that. So do you think if I put minus here and put minus here, did something happen? Right. You realize that this minus 2x plus minus 2x will give us minus 4x, and the product of these two, minus times minus, will give plus. So I think we are there. So the product of this will give this, and the sum of it is going to give us, this is by product and this is by sum, will give minus 4x. All right. So I can now take this and replace this middle term, and I have x squared minus 2x minus 2x, then bring down plus 4 equals to 0. Something so that we focus on this. Okay, and not get distracted with this. So you see, we take this 2 and replace this. I hope we are there. No problem. All right. So within here is, you try to get the HCF, the highest common factor of these two. So the highest common factor here is just x. X is common within here. So you see that I have x here, so that by product, we will return back here, then minus 2. Okay, by product again, you have this. So what about within here? I'm seeing minus 2. Obviously, sometimes you take what is here and then begin to guess what you are going to multiply it with to return back here. I think that should be x that will return us back here. And then this, what will return us back here will be minus 2. Okay? You realize that what we have in this bracket is what we have in this bracket. So I think that satisfies the situation. Okay? So, do you realize that we are going to pick these ones outside the bracket, x minus 2, and the one inside the bracket, x minus 2. Does this look like an expression? Is it clear to us that this is an expression that can be expressed in two factors? This is an expression that can be expressed in two factors. So obviously, this expression is a perfect square. This expression is a perfect square. So the little thing I need to add here is, you now realize that sometimes they can give you an expression and say what must be added to this expression to make it a perfect square. So if I am giving this, right? If I am giving something like this now, part of this, x squared minus 4x, and I'm asked now what must be added to this expression to make it a perfect square. Okay, there are just three procedures you just need to follow, and you get it. 3 procedures. I want you to understand perfect squares. I'm sure that understanding is coming. So in those 3 procedures, one is you locate the coefficient of the variable in question, coefficient of x. Coefficient of x here is minus 4. Okay, do we get? What about the next step, which says take half of it? That coefficient, you take half of it. So we take half. of it, and that's 1 over 2 times minus 4. Of course, it's going to give us what? Of course, minus 2. It's going to give us minus 2. Then the last step is square it. Take the square. Take the square. Take the square. If we take the square, we're just going to have minus 2 all squared. Do you realize that minus 2 all squared is just going to give us 4? So, what must be added to this expression to make it a perfect square? Being an expression that can be expressed in two factors that are the same, that procedure of getting that will be added to this expression is just 1, 2, 3 steps. Get the coefficient of the variable, take half of it, then square it, and that is what you are going to add. Take, for instance, I'm not done. I'm sure we need to understand this thing clearly, and I'm sure you are interested to understand it very clearly so that subsequently you will not have any issue, with all this stuff. What must be this? What must be added to this to make it a perfect square? You'll not be having an issue with that. So let's look at this again. I have here y squared minus 3y, and the question is saying what must be added to this to make it a perfect square. Simply, the procedure, coefficient of the variable here is minus 3. So I have the first step minus 3. The second step, half of it. The half of it is 1 over 2 times minus 3. And that's going to give me minus 3 over what? 2. We take the square. The third step is minus 3 over 2 all squared. You realize that this, now, when I add it here, this expression, y squared minus 3y, then plus bracket minus 3 over 2 will become squared. We become a perfect square. We can also obviously show it. We can show it here. So I have y squared minus 3y. Here, this will become plus 9 over 4. Okay. If I multiply through to simplify this thing further, if I multiply through by 4, I'm going to have 4y squared minus 4 into this will give me 12y. Okay. And 4 into this will give me plus 9. Because if you use 4 times this, it gives you the 4 times this minus 12y, 4 times this. 4 will cancel 4 and we have 9 left equals to 0. You realize that this expression is a perfect square. You can also verify it by doing the factorization. If you do the factorization, you are going to, of course, if you do what I did here, taking product of this and this, you are going to have 36. Yeah, this times this 4 times 9 is 36 y squared positive, and I am breaking it into two factors. That is going to be 6 times 6 is okay. Let me have 6 here and 6 here, and to make it this minus 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 6 minus 6 minus 12. Okay, by sum, by product, it is still here. Let me attach y here and attach y here. So I have minus 6y minus 6y minus 12y. This times this is this. So I think I'm good to go. I can have it now as 4y squared minus 6y minus 6y plus 9 equals 0. The HCF here, I can see that 2 can go here and go here, and y is here, y is here. So let me have 2y outside and have here should be 2y as well, so that this times this will be this. And within here, you have 2 into this is 3. Okay, minus 3. Because this times this will give this. Okay, so within here, let me take this. No, I'm not going to take minus 6 here now, because, okay, it's 3. Minus 3. Okay, here will be 2y, because this times this will give this. Then here will be minus into minus will give plus. So let me put minus 3 here. Okay, so you realize that, okay, what is here is okay. So I have 2y here minus 3 bracket Then in brackets, I have 2y minus 3. Okay, so you see that the expression, where is it again? This expression has been expressed as the product of two factors that are the same. Yeah. Anytime you come across what must be added to so expression to make it a perfect square, you just have those three steps, three of them, and you get what you're going to add. You look at the way I did it. I'm sure that this was able to help. I'm very, very sure of that. I told you that why we brought up this is because we are going to make use of it in the next class when we are going to be looking at solving quadratic equation using completing the square method. And you need to follow us over there. Of course, I believe that that class is also going to be beneficial to you. Okay, right now, please, have you subscribed to the channel? If not, please, it doesn't take anything. Look at that subscription button, just click on it. It's a way of telling us that, oh, what you guys are doing is good. You encourage us, okay, that what we are doing is good, and it's a way of showing also appreciation that, oh, I benefited from you. Okay, you just click on that subscription button. It doesn't take anything, and then you like the video. If you also click on the notification button, anytime we make a video and upload, you are going to see it. Okay, we have a long way to go. What we are going to do, this is almost like a project, and if you're in any way going to support us in any way, yeah, we so much appreciate it. Our email address is there. So once again, thank you for being there.